Welcome back, Math Grizz. Today, we will use the commutative property of multiplication to solve problems. The commutative property of multiplication states that the order in which the same two factors are multiplied does not change the product. Let's take a look at an example. 5 times 3. The 5 and the 3 are known as the factors, the two numbers that are being multiplied. Here we have 3 times 5 equals 15. The 3 and the 5 are the factors. You notice that the factors switched order, but the product is still 15. Let's take a look at an array to see why. We need 5 rows of 3. 1, 2, 3, 4, 5. 5 rows of 3. 3, 3, 3, 3, 3. 5 rows of 3, or 5 times 3, is 15. Now let's try this one. 3 rows, 1, 2, 3 rows of 5. 5, 5, and 5. 3 times 5 is also 15. Remember, the commutative property of multiplication states that the order in which the same two factors are multiplied does not change the product. We have 4 times 3 and 3 times 4. Both have a product of 12. So the same two factors in different order give you the same product. Let's use an array to see why. We need 4 rows of 3. 1, 2, 3, 4. 4 rows with 3 on each row. We know 4 rows of 3 is 12. Now let's do 3 rows of 4. 1, 2, 3 rows with 4 on each row. 3 times 4 is still 12. 6 times 3. 6 times 3 means 6 rows, 1, 2, 3, 4, 5, 6 of 3 in each row. We know that 6 times 3 has a product of 18. If we switch the order of the factors 6 and 3 to 3 times 6, we know the product will still be 18. Just like 2 times 8, we need 2 rows, 1, 2, with 8 on each row. We know that 2 times 8 has a product of 16, so 8 times 2 also has to equal 16. Just like 4 times 1 is 4 rows, 1, 2, 3, 4 rows of 1 on each row. We know the product of 4 times 1 is 4. So 1 times 4 also has to have a product of 4. We have 1 row of 1, 2, 3, 4. Just like 5 times 7 means 5 rows, 1, 2, 3, 4, 5 rows of 7 on each row. We know 5 times 7 has a product of 35, so 7 times 5 also has to equal 35.